Hello everyone, welcome back to our Solidworks course. In this video, we would be creating a manufacturing drawing for a component that we have created in the weldments module. Let's take a look at what the component is. You can see over here that this was the structure we had created using weldments, and in this exercise, we would be creating a 2D drawing or rather a manufacturing drawing for this. Let's move to Solidworks and start creating a drawing. You can see over here I have launched Solidworks and opened the part for which we would be creating a manufacturing drawing. Now let's move into the Drawings tab. For here, I will go to the drop down of New, and here I will select Make Drawing from Part or Assembly. Once you have done this, you can see over here it is showing us the custom template that we had created previously. I will select double click on this template and then open a new drawing. Now you can closely notice over here we have all the details that we had added in our sheet format and in our sheet template. And now that we have clubbed both of them together, you can see this is how the sheet is being created. We had added 4 views in our drawing, that is this front view, top view, side view, that is the right hand side view, and an isometric view. It has also retained the information like the specific appearance for our view over here, and also all the views and the orientation in which they were added. Now I will simply arrange it according to the way I want. Here I will show you one thing, that is how to add alignments to your views. Let's say I will right click on this view over here, and then from the alignment, first I will break the alignment. Now here you can see that this view is free to move individually or independently the way it wants. Again I will right click on this view, go to alignment, and from here I will say align vertically by center. Once I do this and select the view about which it is supposed to be aligned, you can see here that it has created a relation with this. It has been aligned vertically by the center. This is how you add alignments to the views. Now again, you can see here that it can move only upwards and downwards independently, but it cannot slide sidewards independently because its alignment is vertically set with this over here. If I want to move it, I have to move the front view over here. It is good to add alignments so that when you shift your components, all the components are moving in a particular or systematic alignment. Once we have done this, if I zoom over here, you can see that all the details that we had added to our sheet format are being shown over here. It is showing my name over here. It does not have all these information over here because we have not added it in the properties. You can see here that the sheet scale has automatically changed to 1:20 according to the views that we have added. If I click on any of this view over here and zoom down, you can see that the sheet scale is being shown over here, that is 1:20. If I want to alter the sheet scale, I can also do it by using custom sheet scale, but for now we will leave it. What we will do is that we will press Alt Tab and then get into the 3D model, and first we will assign its material over here. I will go to the material. From here I will select edit material, and in the material list I will simply search aluminium. Here we have aluminium alloys. We don't want aluminium alloys. Okay, we'll search for it. Normally we'll go to Solidworks materials. From here we will go to aluminium alloys, and from here I will select any aluminium grade I want. Let's say I will select 5052. Yes, H36. I will select 5052 H36 and apply it to all of our components. I will click apply and then close it. Now you can see that 5052 H36 has been applied to all our components. I will go to the file properties over here, add a custom property, that is description first. I will, let's say, describe it as a structure. You can add any sort of a name that you want. I will press enter and it will show my evaluated value over here. Next, I will add my material. I will select material, and from the drop down I will select material as well again. You can see it is showing me the material that I have assigned, that is 5052 H36. Next, I will go to the drop down, and from here I will specify the weight. I will specify SW mass as the weight. Once I have done this, you can see that it is showing me the weight as 45 kgs. I will click on OK and accept the weight over here, or rather accept all the properties over here. I will change my properties, some of the properties over here. I will go to options. Next I will go to document properties. From here I will go to units and I will set my custom units. Here I will change the mass, the unit of mass from kilograms to kilograms. Once I have done this, I will click on OK. And now if you take a look at the properties, let's say I will go to evaluate, go to mass properties. Here you can see that it is showing the weight in kilograms, 45.53 kilograms. Why did I do this? Because I had assigned the document properties as, or rather assigned the units of mass as kilogram in my document properties while I was creating the sheet template. So it will be reflected in kilograms there as well. It is good when I have to cross verify over here. Once I have done this, I will press Ctrl Q, rebuild the part, press Ctrl S, save it, and then again move back to my sheet over here. Once I am here in the sheet, you can see that all these options or all these data has been loaded over here. It is showing me the description that says structure. It is showing by whom is this being drawn. The tolerances and all can be added by the draftsman, whatever it is. Next it is showing you the sheet scale. Here it is showing you the sheet form or the number of sheets over here. We have sheet 1 of 1, but I guess it has been overlapping number 1 over here. We will arrange it, not an issue. If you zoom over here, it is showing you the material. Again, it is showing you the weight in grams. I will have to modify this over here. Next, I have my date over here. Now I will show you how to modify your sheet format. Let's say now if I try to move all of these over here, they are moving freely. But if I double click over here on the sheet format or this description table, you can see that it is not being shown. This is what mistake beginners do. They create the sheet format outside, or rather they create this description box outside, and then it is never aligned properly. It is always moving around due to some mistake or due to them dragging any entity. So now when we create this in the sheet format, it is now locked and you cannot edit it. But if you want to edit this, you will right click and select edit sheet format. Once you are into the sheet format, you can see that all the views have disappeared and you have only the option to edit your sheet format. From here, first I will change grams to kgs. You can see this is how I have changed it from grams to kgs, and here I will align it so that it fits better. I will first move this one lower over here somewhere. I will now align it like this, let's say. Next I will move my one somewhere over here in the center. I will take this one, move it somewhere over here, and now you can see this is how I have changed my sheet format. Once I have done this, I will simply exit the edit sheet format tab, and now I will edit my views over here like this. Once I am done with this, what I will do in the assembly, I will give it an overall view. I will get into the smart dimensions command and I will give it overall dimensions like this. Let's say I want this to be over here, this to be shown over here. Next I want this dimension to be shown. I will delete this. Next I want this dimension to be shown over here from this edge till this edge over here like this. Once I have done this, I will show the distance between these legs over here. From here till here, you have to be very careful while selecting the edges so that you don't select the wrong edge. This is my dimension. I will zoom in, select the outer edge for these bottom plates over here that are acting as your supporting plates. I will press it over here. I will set it over here. Next, I will specify this length over here like this. I will specify the length of the width of these legs over here. So basically, you are seeing that whichever entities I am selecting, it is giving me an option between both. It is giving me the dimensions between both these entities. Now let's say if I want to specify the angle at which these two would be mounted, I will simply select both of these entities And you can see here, this is how it is showing me an angle at which these would be mounted. This is how you can add all the dimensions. Here I will zoom in and change the appearance of my isometric view to shaded with edges so that I can get a more realistic view over here. Next in the drawing, I will show you how to add your labels for these drawings. You can either go to note and then simply add a note over here and add, let's say, top view. I will say add top view over here. You can see this is how I have added a label. But let's say if I try to move this drawing, I will now first break its alignment. So yes, okay, let's say I am trying to move this line over here. You can see that the label is moving along with it. So this is why you have to add the label properly so that it is being aligned to your drawing. Again, I will set it at an alignment, align vertical by center. I will select this line over here and it is now again aligned. The next way of adding your label is that first I will delete this one. I will right click over here and here we have an option that says add view label. You have to do it twice because it is in the same. This is basically used to specify the view or the scale of your model. But we add it because it is convenient. You don't have to drag your note over here and then bring it over here. I will click on this over here and then I will add whatever my view name is. I will enter in the uppercase. I will say top view and I will press escape. You can see that the top view has been added. Again, if I try to move it, it will move along with my view. Now here I will show you what happens when you change the scale of your model. Let's say I select this model over here and then I will say use custom scale. I will place my cursor over here and use my scroll button in order to change the scale. You can see it is using all the custom properties that it has. That is the custom sheet scales. That is, it has over here. It will scroll through all of these one by one as you scroll your button. But let's say I want it to be 1:25, let's say. You can see that now I have changed my scale. I will click on OK. And now if I try to add a view label, let's say I say add view label, you can see that when I add the view label, it shows the scale of this model over here by default. But I can again edit it, double click on it, and I will say front view. I will press escape and this label has been added. Again, I will set it back to the custom or rather the sheet scale, that is 1:20. I will click on OK and you can see here that I have added the view label for this. Again, I will right click on this, click on add view label, do it again. And I will drag this somewhere down over here like this and give it a label, that is double click on over here and I will say side view. This is how I have added view labels to all our drawings. I will add another view label to the isometric view. I will do it again twice so that the view label has been added. Here I will add isometric view. Once you have done adding all the labels for these views, we will move back to our part and take a look if all the components or all these members over here have been assigned the proper properties before we add our cut list table. I will press Alt Tab on the keyboard and then get to the cut list over here. I will first expand it from here and then I will right click on the first cut list item over here. I will go to properties and here you can see we have all the properties for our cut list items. I will align it properly so that we can take a look at our model as well and also at our cut list properties over here. The first one we have selected is the C channel over here. You can see we have all the properties over here like the length, the angle, it is a straight one so we don't have an angle. Next we have a description, that is the section of our channel. Next we have the material, that is aluminum 5052H36. Next we have the quantity for this and also we have the total length, that is these two combined. We don't need that as of now. Next we will go to the C channel, that is these long ones over here. We will cross check if we have all the parameters. We have the length, the description, next we have the material, quantity, all of these are there. We will go to the next section over here, that is this L angle of 80 by 80 by 6. We have its length, we have the description, we have the material over here, and the quantity as well. You might be wondering here, why have these two only been selected together, and why not 4 of these when we have 4 of these legs over here? It is because Solidworks differentiates these members on its profile. For example, what would have happened here is that I will show you first with the example or with the help of a small sketch over here. Now only these two are being shown in the same group, and if I go over here, that is 80 by 6, second one, you can see that these two are being shown in the same group. Now why this is happening? Because the holes we have created on this, you can see that we have these holes over here. If you try to rotate this part and then assign and then keep it together, you can see that these two would be in a similar orientation. That is, you have to create two quantities of these over here. And if I select this item from the cut list, you can see that the holes are on this surface. If you rotate this part and imagine that these two are kept aside, both of these would be symmetrical, or rather both of these would be identical. And I will have to create two quantities of these. This is how SolidWorks differentiates your members, so that you get a neat cut list which could be provided to the manufacturer directly. But it is a good practice to check all of the details in your cut list. I will clear all of it from the screen, and we will move to the next cut list item that we have over here. We have these 4 plates over here in our cut list item. You can see that it only has the material and quantity. It does not have a description over here. We will add a description and we will call it, let's say, our mounting plate. Once I have added the description, I will press enter. I will move ahead and check my next member in the cut list, that are these 4 supporting members. You can see that it has been given the description, that is its section 50 by 50 by 4. I have its length 525, and all the lengths or all the holes would be specified later. Next, I will move to the cut list item over here. You can see that these plates at the bottom also do not have a description, so I will add a description over here. I will select description and I will call them the bottom plates. Once I have done this, I will press enter and select the evaluated value over here. We will move to our next cut list item, that is our cross braces over here. I will enter the description and then give them a description, that is cross brace. Once I will press enter, you can see that the value is being shown over here. I have made a small spelling mistake, so I will rectify it and again press enter. You can see now it is again showing a new evaluated value. As SolidWorks has grouped all of these cross braces into one group, we can be confirmed that all of these are nearly, or rather completely identical. So we can add a length over here. We will select length, and from the top down, let's say we have length over here, we don't. What we can do is that we can simply measure it over here. I will zoom in, select this edge over here and note the length over here that says 1099.11 millimeters. So we can simply enter 1099.11 millimeters. This is not the length that can be accurately created. So let's say we can round it off and we will make it as 1100 millimeters. I have entered 1100 millimeters, and rather let's not add millimeters. We will simply add 1100 and press enter. You can see that now the value is being shown over here. That is the length of this section. Next, I will go to this one. You can see that now all the properties for this have already been added. I will click on OK and then I will press Ctrl 7, set it into the isometric mode, and I will move back to my drawings by using the Alt tab. Here you can see this is how I have added my views over here. I will again create a new sheet. In this, I will add a simple isometric view just for reference. It is asking me to refresh my view palette. I will refresh it from here. Again, I will add an isometric view over here like this. I will set it to shaded with edges. Next I will do is that I will reduce its scale size. For that, for this purpose, I need a very small scale. I need this just here for the reference. What I will do is that I will go to annotations, and from the table or the drop down of table, I will select weldment cut list. It is asking select a view for which you want to create a weldment cut list. Now you know why I have added the view over here. I will select this, click on OK, and here you can see my weldment cut list has been generated. Once we have our weldment cut list over here, we will now simply modify it a bit so that it is looking proper. You can also modify the width of this table over here, that is quantity, item number. We will add a new column over here, that is we will right click over here, go to insert column on the right, and we will specify cut list item property, and here we will specify the material. We don't have a material over here. Yes, we have. I will select material, and you can see that it is now showing me the material for all these members over here. Again, I will add a new column on the right. From here I will go and select cut list property, and from the drop down I will select. Okay, we cannot select weight over here because we had not added weight in our previous, or rather in our properties. So what I will do is that I will cancel this out. I will again press Alt Tab, go to my cut list over here. I will select this first member, go to properties, and then add a weight column. For that I have to simply go to over here, give a new property, specify weight, specify mass over here, and you can see this is how it is showing me the weight for this section over here, that is 3.88 kgs. Again I will go to the next one over here, specify weight. Length is a duplicate property name. I guess I had selected length by mistake. I will select weight very carefully, go to this drop down, select mass over here. You can see it is showing me a mass, but why is it showing me in grams? It should have been shown in, okay, I had by mistakenly selected volume. I have to select mass. Okay, now it is showing me the mass, that is 8.8 kgs. This was a small mistake. You have to make sure that you select the properties properly. Here I will select weight. Next I will select mass. This is 2.43 kgs. I will go to the mounting plate, go to this drop down over here, select weight, and then from here specify as mass as my driving factor. Again I have selected volume by mistake. I need to specify mass. You can see that the weight over here is 0.35 kgs. We will move ahead and give the or add the weight property to this over here. I will select weight. From here I will specify mass, and it is already showing me the weight for this component. I will move to the bottom plate, give it a weight, also assign my value as mass. It is showing me the weight as 0.84. I will now do the same for my cross brace. Go to weight. From here I will add mass, and it is showing me the mass or the weight for my cross brace in kgs. I will do the same for these two members. Go to weight. From here I will specify the mass as my value, and here it is showing me. Again I have by mistakenly selected volume. Here I will select mass again, and you can see here it is showing me the weight. I will click on OK, press Ctrl Q in order to rebuild this part, press Ctrl S to save it, and then get back to my drawing sheet by pressing Alt Tab. Once I have done this, I will add a new column over here, insert column right. From here I will select cut list item property and select weight from here. Now it is showing me the weight option. You can see that this is how it is denoting the weight. Okay, let's take a look at why this is not showing all the other weights over here. For that, we will again get back to our part. I will press Ctrl Tab and again edit these properties, right click, go to edit. Here you can see somehow it has not saved this property over here. We will have to add it again. I will again select weight. In value I will select mass, and I will do this same for everyone, or rather all the members where it is not showing me a weight. It might be some sort of a glitch where it had not selected or it had not entered all these properties. I will again do the same for everyone till I get a confirmation that the weight was added. For all the components, I will again cross check all of them. I guess, okay, this one has it, this one also has it, this one also has it, and this one also has it. Yes, it has a weight. The last one has it as well. I will click on OK, save these, press Ctrl Q, rebuild the part, press Ctrl S, save all the properties, press Alt Tab and get back to my sheet over here. Now here you can see that it is showing me an option, or it is showing me all the weights that were required here. Next, I will edit this heading over here. You can edit all of these headings by simply double clicking on them. You can see here that now it is showing me the option to edit it. I will press spacebar. I will add a bracket and then add kg as my unit. I will escape caps lock. I will add kg as my unit over here. Once I have done this, I will now simply press enter. Next, I will add a unit for the length as well, that is millimeters. I will do the same over here. Press. I will press enter over here. You can see the units have been added wherever necessary. We will now simply arrange them so that they look good. It is not looking professional or systematic here. I will press spacebar until it is moved to the next line. I will press enter, and this is now this looks good. I will do the same over here. Edit this from here. Press spacebar until it moves to the next line, and I will press enter. Once I have done this, what I will do is that now arrange the table properly. Say like this. Now I will arrange my table over here like this. At the corner, let's say, or let's say I will arrange my table at the bottom side over here. Alongside my description box. I will align it so that the length or the height of this is matching. I will drag it back over here. You can also, I will select this row and then reduce its height. Like this, I will make sure that it is matching. Okay, this is the max we can go. I will leave it here, and this is how my table is looking. Now what I will do here is that I will expand this, or rather enlarge this a bit. Let's say I want a sheet scale size to be 1:30. Yes, now this is proper. We can see all the parts properly. Now what I will do is that I will zoom in a bit, and then with the help of ballooning, I will make sure that with the help of ballooning, I will show where all my parts lie. I will select this balloon option and then specify all the parts that I want to. Let's say this one. This leg is number 3 over here, that is a member of 80 by 80 by 6. I have to specify this leg separately as it is being created in a different orientation. It is being shown as number 8 over here, you can see. Next, I will show this frame or this member over here. Next would be this member over here like this. Next is this cross bracing over here. Next we have our cross bracing over here. I have this bottom plate over here like this. And then I have my mounting plates. That is this one. I will zoom it so that I am selecting it properly. I will select this mounting plate and then move my balloon over here somewhere. Let's see if I have added all the components. That is, I will just check the number simply. 1, 2, 3, 4, 5, 6, 7 and 8. Yes, I have created a balloon for all of these. Now I will simply arrange these balloons so that they are organized or arranged in a systematic order and they don't look as if they are added just for namesake. This is how you can add your ballooning. We can keep this over here like this. Now this looks okay. Once we have added all the ballooning, what the manufacturer can do is that he can take a look at these over here, and let's say if the first one, he will take a look at this item number 1. I have to create 2 quantities. The description tells him what kind of a member it is supposed to be used. a C channel of 120 by 12. Next, he knows at what length he is supposed to cut it. He will cut it at 905 millimeters and the material he will choose is 5052 H36. He will approximately compare the weight with his final product, and here he will take a look at how this has been added. Here you can see number 1, this is the plate which is supposed to be added. But next, once we have created this, you know that we have a lot of holes in these components. How do you specify those components? For that, cutting these are quite simple. He will take a C channel of 120 by 12 and then he will cut it for this length. There is no special manufacturing except for the holes in this. But how will he generate this mounting plate over here? He does not know anything about it. Neither does he know about its dimensions, nor does he know about the plate thickness. For that, what we will do is that we will add something, that is the relative view. I will go to drawing over here. From here, I will select relative view. This is my relative view over here. Yes, I found the relative view over here. This will take you directly back to your model. Let's say I want to create a relative view for this one. It is asking me to specify the orientation, that is front. I can also, let's say, specify the top. I select this front orientation, select this top orientation and click on OK. It will again take me back to the drawing and I have to add it over here. But this is how it has been added over here. If I zoom it over here, you can see that all of these components have been added. For this, what I will do is that I will select this, open my part, and from here I will go to the configuration manager, and here we have something that says display states. Let's move ahead and add all the other components that would be required in order to create this structure over here. For that, I will introduce you to something that is called as relative view. I will select it from here, and it is asking me for a face or a model or graphics area in another window. To open a model, let's say I will specify this model. It will take me back to the 3D model over here, and from here first I will change my scope from entire part to selected bodies. It is asking me what body do I want to specify. I will specify this body. Once I have specified the body for which I want to create a relative view, I will specify some orientation. Let's say in the front orientation, I will specify this face, and in the top orientation, I will specify this face over here. Once I have done this, I will click on OK. It will take me back to the drawing, and you can see here this is how it is giving me an option to specify this plate over here. Now again I can click on OK. I will click on this plate over here, go to projected views. OK, it has taken back me to the part. I will click on this view over here and select projected views and project all the other views. Right view would be like this, and the top view would be like this. I will press escape and select all these 3 views, and I will increase the scale. I will say use custom scale, and I will increase the scale like this. Let's say I want a custom scale of 1:12. I will click on OK, and this is how it has created a scale. But you can see that the alignment has been changed. There are some issues with the alignment. So what I will do, I will right click on this view, go to alignment, I will break alignment. Again, I will go to alignment over here, select align vertical by center, and I will specify this view. Now you can here see that it has aligned them perfectly. I will add a new note over here. I will go to annotations. I will add a new note over here that says mounting plate. And this drawing is for mounting plate. Let's enter them as uppercase mounting plate. Yes, once I've done this, I will press escape, and this is how I have created a separate drawing for my weldment component for this. And from here, now I can go ahead and specify all the details in my drawing. I will get into the Smart Dimensions tab. I will go here, specify this length over here. There is some issue. I will delete this, select this, delete it. Okay, I am into the sheet, that's why it is giving me the issue. I will go to, let's say, standard sheet. I will get into the smart dimensions command and then now give it a value. Again it is causing an issue. Let's say we will delete it again, change my view to say none, or rather layer to none. I will get into smart dimensions and then now try giving it a dimension over here like this. Again it is showing me an issue. Let's try using the control Q. Yes, by using the control key cube, it has rebuilt the part and set it normal over here. Next what I will do is that I will get into smart dimensions command again and then specify the thickness of this plate over here like this. It is of 6 mm thickness. I will specify the height of this plate and now I will specify the holes over here. Let's first specify the holes from this bottom edge over here. I will zoom in and select this center edge. I know that these are at 77.78. I will add another dimension over here that says 35.36 for the holes between these two edges. Next, I will get into the smart dimensions again and specify, now that we have specified the vertical distance, we will specify the horizontal distance for these holes. It is giving me an angle. I need to zoom in and select this edge properly. Now that it is giving me a distance, I will make these arrows from inwards. Okay, it is not working. This is looking proper. I will get into the smart dimensions again and specify the distance between these two holes over here like this. Once I have added all the details, you can see that now it is ready to be submitted to the manufacturer and the manufacturer can now create this part. Here you can see that we have some values over here which are in decimals. Basically it is not possible to achieve this accuracy. So in Solidworks we have an option to round this off. I will select this value, go to this precision over here that says round off. Here from here you can see here that some dimensions over here are in decimals and it is practically not possible to create or replicate these dimensions while manufacturing. So what we will do is that we will select this dimension, go over here and round off them to 1 decimal digit. You can see it has made it from 43 to 4. If you make it to none, what it will do is that it will round it off to the nearest value according to the dimensions. Let's say now this rounded off to the bottom value. Let's say if I try rounding off this to none, it will round off to the higher value because the number was nearer to the higher value. We will do the same for all these over here. You need to assign your dimensions properly so that this problem does not arise. So now that I have given them dimensions properly, you can see that this is how my dimensions have been added. Here I must also specify the angle at which this cut would be created here. So I will select these two and then give them an angle like this over here. Yes, now here it is an angle of 135 or rather an angle of 45 degrees over here. Once we have done this, I will specify the angle between these two over here as well. You can also create a center line over here or a construction geometry over here which you can use in order to give your angles. Let's say I create a line over here, select it and make it horizontal, has a horizontal relation. Now I will get into the smart dimensions and then give this an angle over here like this. I will create an angle between these two. You can see the angle is showing as 45. It is asking me if I want this dimension to be driven. I will say yes, because it is a dimension which is supposed to be sent to our manufacturer. I will arrange it properly. Here, let's do one thing. Let's increase the scale of this over here. I will select all of them and then again reduce the scale so that it becomes bigger. Like this, I will say let's make it 1:4. I will click on OK, press Ctrl Q. I guess the changes have not been made. I will again select all of them, go here and manually type 1:4. When I enter, you can see that the scale has been changed and now I can align them properly so that the dimensions do not overlap. I will select this Specify this dimension from the outside like this, zoom in a bit, click on this point over here, and okay, now this is being shown from the outside. Now I can turn the arrows inside over here. This should be somewhere over here like this. This is over here. What I can do is that I will again create a center line over here like this, which is horizontal. I will end the line, get back into the smart dimensions, select these two lines, and then give another angle over here that is of 45 degrees like this. Let me position it properly. It is okay, yes. I will click on OK and give this dimension over here. Now you can also hide these lines I have created. Let's say I will go to the layers option over here and I will create a new layer that is for, let's say, reference geometries. I will say select reference and then make this layer hidden. You can see now the layer is hidden. I will click on OK. From here I will select this line, select this center line, rather the construction geometries, and assign them to our reference geometries. Now they would be hidden. This is how you can use the reference or hide the reference geometries. But in this case over here, it was not a good idea to hide it because we need this line over here in order to define it. So what I will do here is that I will go to the reference geometries tab and I will go here, make it visible, and now you can see that the line is being shown. I will select both of them again over here. I will cancel this first. From here, I will enable the reference layer, but first I will have to make it visible. I'll click on OK, select both of them over here, and then bring it back to none of the layer, that is the normal one. Now it has been shown. We need this line in order to create this reference. But when you create certain reference points, you can hide them because they do not look good on your screens, or they look like unnecessary details. Once I have given them all of their dimensions, now this plate can be clearly manufactured by a manufacturer. Next, we will do this for our next member. What I will do, I will again go to drawings, select our relative view. Next, I will select the model from which I want to create my relative view. I will now create a relative view for these over here. Okay, it is asking me to first specify the part for which I want to create it. I will specify the part, that is this one. In the front view, I will specify this face. In the right view, I will specify this face. Once I am done, I will click on OK and then we are back here. You can see this is my front view. I will now select projected view. This is my top view over here and this is my side view over here. I will press escape, get into the smart dimensions command and give it its dimensions 125 by 125 and the thickness is 20 millimeters. Once I have done this, I will select all of them like this and then change its view or the scale. Let's say we again give this a scale of 1:4. I will click on OK and then generate it. I will press Ctrl Q to rebuild it. I will check if it has taken. Okay, it is still in the 1:8 scale. I will press escape, select all of them together by pressing Ctrl. Again from here I will enter 1:4 manually, press enter, and now you can see that it is now in the 1:4 scale. But the alignment has been destructed. You can see that on moving this, all of them are moving. I don't want it to happen that way. For this, I will select this and I will say break alignment. I will move it over here. I will move this body over here first. Move this over here like this. Bring my square over here. I can position my dimension like this. Yes, this is how I want it. I can shift this one upwards a bit so that there is no overlapping. I can move this downwards, move this upwards a bit. This is how you can see that I have added views. This is the mounting plate. Now I will position these views over here. Okay, I have not made an alignment. I will right click, go to alignment, align vertically by center, and I will select this one. Now that these are aligned, I will place them accordingly, and then next I will add the name over here. Let's say I move this upwards a bit, this one too, and then I will add a note over here that says bottom plate. Once I have done this, I will arrange this properly, and now you can see that I have given all these dimensions in order for this part to be created. Once I have done this, what I will do here is that I will move ahead and then create a relative view for another component. First, let's take a look over here. These arrows or these dimensions over here look faint. I will select all of them and then change its layer. Let's say I want it in the reference layer. I will click on it, and now these are back to be black. Once I have done this, I will now arrange it somewhere over here and add a view for another of a component. I will go to drawings. I will select relative view, specify this component, and again when we are back over here, now I will specify. Let's say I will select this over here. For this, what I will do is that let's select this leg over here. For this, I will go and selected bodies. I will select my scope. This is my body, which is what I want to be created. I will specify the front face as this, specify the right face as this. I will click on OK, and here I will add my body. You can see this is how my front view has been added. I will go to projected views, add the side view, and also add the top view over here. I will press escape, zoom in, and begin with my dimensioning. I will give this a dimension that is 80. I will give its length over here. I will select it, give its length over here, that is 975. Next I will zoom in and give it its dimensions over here. This is an angle of 80 by 80. This is how I will dimension it. These are standard components, so you don't have to give them a lot of dimensions, but you need to specify the dimensions of these holes over here. These holes are at a distance of say 40 millimeters over here like this. I will just press escape, exit the dimensions, smart dimensions command, move this upwards and drag this downwards so that it is over here. We technically don't need this dimension because we have given it over here, and the projection will show that this length would also be 80. I will move this over here so that now we know that these holes are horizontally at a distance of 40 millimeters from this edge. Next, again I will enter into the smart dimensions command, select this over here, zoom in. You can directly select the circle. It will give you the center distance like this. Now next I will select both of these circles, and now I will give a center distance between both of them over here like this. This is a tricky one to give because it is overlapping all of the other dimensions. I will click on OK here, and you can see I have added it temporarily for over here. I will move this away so that now the dimensions are not overlapping and be clearly seen over here. Once I have done this, you can see that I have defined all the parameters that were required in order for this part to be created. Now the manufacturer can easily create this part. What he will do is that he will take a section of 80 L section of 80 by 80 and of thickness, which I have to specify over here, of thickness 6 millimeters. Next, what he will do is that he will cut it for a length of 975 millimeters, and then he will drill these holes, which are at 40 millimeters horizontally from this edge, 35 millimeters from this top edge over here, and 50 millimeters the distance between both of them. I will assign it over here like this. Okay, now that I'm satisfied that my dimensions are accurate, I can move to the next one. But first, I will add annotations over here. This annotation would tell me what is this member. I will cross check it from over here. It says 80 by 80 by 6. I will add it over here and say 80 by 80 by 6. You can add member over here. Let's say member, or let's say structural member 80 by 80 by 6. Now that we have defined its name, the manufacturer would know how it's supposed to be created. I hope now you have understood how did we create this drawing and how did we specify views for each of these members that were required in order to create these drawings. I will give you a homework exercise. You have to continue this drawing and you have to create the drawings or detailed drawings for all these members over here. You have to create relative views for all these members and then specify them or define them by using the dimensions. You need to make sure that the dimensions are enough in order for this part to be created. I hope the sheet that we created before was clear as well. You were clear with the part of how you add all these views over here, and then also how you make changes to the scale over here. Also, this part is clear where you can see that we have automated our description over here. We have automated the material over here, weight, date, sheet, and the sheet scale. Whatever extra notes you want to add, you can simply add by using the note option over here in annotations. I hope now you have got a good hang of how 2D drawing sheets are supposed to be created, especially when they are supposed to be submitted to a manufacturer. Also, I hope that this weldment cut list is now very clear and how do you make changes at it. Also, the ballooning of all the components is I assume very clear to you guys as well. I hope that now you are capable of creating manufacturing drawings by yourself. I expect you to complete this drawing, add all the remaining views, that is relative views for all these members, and then create a PDF for it. I will show you how to create a PDF. You simply go to here, save as, and from here you will specify your type or file type as PDF, save as PDF, and simply you will save it. This will give you option over here. It is asking what sheet do you want to be exported as PDF. You can select both of them. I will select both of them by pressing shift and I will click on OK. This is how a PDF would be created for my drawings over here. I hope this was a fun exercise and you got to learn a lot. Yes, I know this was a heavy exercise and that it might have tired you. Take a break and continue with the course later. I will see you in the next video. Thank you.